Hello everybody, welcome back to another calculus video. Today I wanted to go through a related rates problem. The related rates problems, there's a lot of different kinds that can show up. This one in particular is about the angle that a ramp makes, just I guess the angle that a ramp makes and kind of the slope of it. This kind of problem, so you're thinking of a ramp, we're thinking of a triangle shape. And another kind of style of problem I've seen is sometimes they'll say like a ladder leans against a wall. That's going to be kind of exactly the same strategy that we use in this problem. I'm trying to think if there's anything else I want to say about, this before we get started. So I have a problem here that was requested. So I'll read it and then I'll show you how I like to approach this. So it says, suppose that a ramp makes an angle of alpha degrees with the ground. If the ramp has a slope m, then we can relate the slope of the ramp and the angle the ramp makes with the ground according to, and then this equation. If you're like, where does this equation come from? I'm totally confused. Don't worry, I'll show you where that comes from. And then the question is saying, well, if the angle of the ramp is increasing at a rate of 3.4 degrees per minute, what is the rate of change of the slope of the ramp at the instant when the slope is 3? So a lot of things going on here. I think the key to related rates problems is, unpacking the information we're given and taking it one step at a time. And for related rates, I think the first step is always, draw a picture. Let's see what's going on. So like we said, we have a ramp. So let me just start by drawing, a picture of a ramp. So let's say like this, like this, like this. So here's the ground. Here's the ground. The slope of this line, well, we know that's m. Well, let me start I'm going to start by labeling alpha. So because alpha is the angle that the ramp makes with the ground, so let's call that alpha. Now, this is a right triangle. It doesn't say that anywhere, but that's just a key assumption we're going to make. And then, okay, we know that the slope m, or the slope is m. Well, slope is rise over run. So rise, let's call this y, run is x. And if we think about, our trig functions, we have sine, cosine, tangent, and maybe you'll remember from previous math lives, well, we have so, ca, toa. And what that, does is it says sine is the ratio of the opposite side of the angle to the hypotenuse, cosine the ratio of the adjacent to the hypotenuse, and tangent of the opposite to the adjacent. So if we look at alpha here, well, if I do opposite over adjacent, I get y over x. So tangent of alpha equals y divided by x. But y is the rise, x is the run. Well, rise over run is slope, and we know the slope is m. So I'll put here slope equals m. So we're saying tangent of alpha is equal to m. And arctangent, that's the inverse function to tangent. If I apply it to both sides, arctangent of alpha is alpha. So alpha equals arctangent of m. Now, this is really close to the formula that they've given us here. But what's happening here is they're actually converting from degrees to radians. So alpha is given to us in degrees. So maybe just as a little bit of an aside, I know that pi radians is equal to 180 degrees. So what that means is that pi over 180 radians is equal to 1 degree. So then alpha is in degrees. What this means is that pi over 180 times alpha radians is equal to alpha degrees. So all that's happening in that equation that they give us is that they're converting to radians. So I'll write that down here. So converting, so I'll say with conversion to radians. We have pi over 180 alpha is equal to arctangent of m. All right, very good. So that's where that equation comes from. The other part of this problem that I want to go through is like, what's the actual situation happening? Because I think if it's your first time seeing one of these problems, it might be a little bit confusing. So I want to draw a picture of what's happening, or a visualization. If I had animation skills, I could make a little animation. Maybe that's for the future of this channel. But right now, what's happening, or the best I can do is basically say, well, what and I'll go back to the problem so that we can look at it by saying, okay, the angle of the ramp is increasing at a certain rate. So we're changing the angle here of the ramp. So as time goes on, maybe now this is my new ramp, right? So alpha's gone from that amount to this amount. And time keeps going on, then maybe alpha gets even. So I'm gonna actually go off of the, or I'll run out of space. So let's make it a little bit smaller, and I keep increasing alpha. But what you can see happening is, notice the slope is changing as alpha is increasing, right? So it's saying we want to find what is the rate of change of the slope of the ramp at the instant when the slope is 3. So we want the rate of change. So how quickly is the slope changing? And we're going to do it at the instant when the slope is exactly equal to 3. So this is a visualization of what's happening. You can imagine, I'm increasing alpha and these triangles are getting bigger. The angle here is getting steeper. We have our equation here. Now, the thing I want to point out, so for related rates problems, it's extremely important to identify what's changing with time and what's staying fixed. So when we look at alpha is changing, right? They tell us that in the problem. Alpha is a function of time. So alpha equals alpha of t. In words, this says alpha is a function of t, time. The other variable we have here is m, the slope. Now, in some related rates problems, you have multiple variables and some of them stay fixed, some of them don't. In this problem, notice the slope is changing. So the slope is also a function of time. The slope is changing with time. So m is also m of t. What this tells us is that when we differentiate, we're going to need to be very aware of this and use the chain rule. So I'm going to differentiate both sides. So pi over 180 times alpha, well, this is constant times a function, so this is going to be pi over 180 times alpha prime, that's the derivative of alpha, equals, now, what's the derivative if I just had arctangent of x? The derivative of this, does anybody know before I write it down? This is 1 over 1 plus x squared. Definitely something you should know. I've been saying this, for as long as I've been teaching calculus. Professors love arctangent. It always is going to show up, so highly recommend this is one of the derivatives that you have memorized. But okay, arctangent of x is 1 over 1 plus x squared. So then here we have arctangent of m. So okay, we'll have 1 over 1 plus m squared. Now if I stop here, what's wrong? Is that m is also a function of t, right? So I need to use chain rule now. I did derivative of outside function, arctangent. Now I need to do times derivative of inside function, that's m prime. Okay? Remember, what are we solving for? Let me go back here. So we want, what is the rate of change of the slope? Well, that's m prime, right? So this is what we're solving for. We want it at the instant when the slope is 3, so when m is 3. So we want m prime when m is equal to 3. And what else are we given? So we know that alpha, the rate of alpha prime, so the angle of the ramp is increasing at a rate of 3.4 degrees per minute. So we're also given that alpha prime equals 3.4 degrees per minute. Oops, it's not letting me do per minute. And then maybe I'll say here when m prime equals, did they give us the unit for the slope? No, that's fine. All right. So let's plug in. And actually, slope is going to be unitless, right? Because if slope is rise over run, it doesn't matter what, if this is in feet, this is in feet. Feet divided by feet is gonna cancel out, right? So disregard what I said about that. But now all we need to do is plug into this equation, right? So, and we'll solve for m prime. So I know we have pi over 180 times 3.4. Maybe I'll put here degrees per minute. Equals 1 over 1 plus m squared, m is 3, so 1 plus 9 is 10, times m prime. I'll multiply by 10 on both sides. So 10 pi over 180 is pi over 18. So pi over 18 times 3.4 degrees per minute equals m prime. And this will be our answer. So, this is just one style of related rates problems. There's so many of them, so I think I'll probably go over some more in the future. But for now, let me know if there's any questions or concerns in the comments. And thanks for watching, and I'll see you in the next video.